Welcome to the project demonstration of environmental parameters monitoring robots along with IoT visual controlling from the browser. So here we are going to get the visuals of this camera, that is ESP32 camera. That visuals can be seen on the Google Chrome or the IoT, and we can control the robot movements from the browser only. Like we can control the robot in forward, backward, left, right, along with headlight controlling. And the next feature is, like in our project we are using three sensors. One is MQ135 air quality sensor, and MQ07 gas sensor, and DHT11 digital humidity temperature sensor. These four parameters continuously monitored by this Arduino Uno, and the same details will be uploaded to the ThinkSpeak cloud platform using this ESP8266 Wi-Fi module. So in our project, ESP32 camera to control the robots and headlight controlling, and Arduino Uno to get this air quality MQ135, MQ7 gas, DHT11 humidity temperature sensor, and upload to the ThinkSpeak using this ESP8266 Wi-Fi module. And to control the robot movement, we are making use of a motor driver, that is L293D motor driver, which will take input from this ESP32CAM and control the two DC motors attached to this robot with forward, backward, left, right, and stop motion. And the whole system getting power supply from this 12 volt 2 amp battery pack, which is rechargeable battery pack. In this one we can see the 6 batteries are connected. In that, three set are connected in series. So each battery, a small battery voltage is 4 volt 1 amp, and 3 numbers are connected in series, so we'll get 12 volt 1 amp. And this is a 12 volt 1 amp set. These two are in parallel, so we will get 12 volt 2 amp DC output directly. And this one is the main on-off switch to provide the power supply to the whole kit. But the operating voltage of our Arduino Uno and ESP32 camera and the sensors is only 5 volts. In order to regulate that 12 volts DC to 5 volts DC, we are going to in order to regulate that 12 volts DC to 5 volts DC, we are using LM2596 voltage regulator, which will take 12 volts DC input and provide as a 5 volts DC output to this breadboard. So from this breadboard, we are distributing that 5 volts power supply throughout the input and output modules. So here the first step before demonstrating this project, keep this battery under fully charged. So for that purpose, just connect this B battery at this slot. Okay. So now connect the battery pack at this shown slots. Okay. And now on the power supply to this transformer. So the transformer will step down the 230 volts AC to 12 volts of AC, and this charging circuit will convert the 12 volts AC to 12 volts DC, that is the charging voltage of our battery pack. Keep the battery back under charging whole night. So if the battery getting fully charged before the time completes also, no need to worry about that. These diodes will block the current flow from the charging circuit to the battery in order to protect the battery from overcharging. So once the time completes, you can disconnect that. Means it will take minimum of 6 hours, maximum 8 to 10 hours to be fully charged. So disconnect that and keep aside. So the next step is go to your phone hotspot settings, and I'm explaining that in Android phone. If you are using iPhone, you need to change the iPhone name for this hotspot settings. So configure that hotspot settings to project PROJECT 6011. All are small letters without any space, without any capital letter, and password should be 123456789, and AP band should be 2.4 gigahertz. After these settings done successfully, enable the hotspots, and the next install the network analyzer application from the Play Store. So this is the application icon. So the purpose of this application is to get the IP address of our ESP32 camera. After this, now you can on the power supply to the kit. Right. So now in your hotspot settings, you can see that two devices will be connected. So two devices connected. In that, one is ESP32 camera, another is ESP8266. Options: LAN scan. Do the scan. There we get the two IP addresses, and in that, copy any one of them. One is your mobile phone, another two is the ESP32 camera and ESP8266. Copy any one of them. Go to Google Chrome and paste it on that. So we are getting the visuals. So if you don't get the visual, copy the another IP address. Right. Okay. Let us control the file to control the robot movement. So press and hold the respective button. Right, and headlight on off also. Okay, this is the controller section, and meanwhile the system is uploading the data to the ThinkSpeak with help of this ESP3CAM, as we need to provide the data also. It's the main thing. Don't forget to provide the data. Right, so this is the previous data which we have got. So if you want to get the fresh data to be seen, you can erase that. Before erasing is my suggestion to download the data in Excel sheet format. Means we can maintain the database. Just download that. It will be downloaded in Excel sheet and open. Fine, right. So the data is downloaded, and you can see in that one the first column is going to be the date and time, number of entries till now taken, 28 samples till now taken, and first one is going to be the humidity and the temperature and air quality and gas. So in ppm. So these are the details, and now we can erase that as we took the backup. So for that, go to channel settings, and in that only do clear channel. So after the channel got cleared successfully, now you can go to private view. So in the while scrolling, don't touch on this blue bar. So between that, scroll with help of that, so you can get the continuous. The first one is humidity and temperature in degree centigrade, air quality in ppm, and MQ7 the gas in ppm also. So if you want to increase this one, just to provide the input to the sensors for the gas, we can use the lighter which can provide the LPG gas input, and for the air quality we can provide the smoke input. Just provide this. So wait for only gently press, you will get the gas. Right. So the data interval is to upload the data to the ThinkSpeak is 15 seconds of duration. So whenever you uploading the data to ThinkSpeak, it can accept that for every 15 seconds only. If you upload the data before that, it won't accept that. And let us see the robot demonstration on the floor. Right, we can see the raising in air quality along with MQ7, as we have provided the input from this one. When we click on that, we can see the air quality in ppm, as well as here also like MQ7 inputs. So let us see on the floor.